Math Blast 16. I can solve multi-step word problems and interpret remainders. Basketball sign-ups were held over 3 days. Friday, 17 players signed up. Saturday, 12 players signed up. And Sunday, 10 players signed up. If it takes 5 players to make a basketball team, what's the greatest number of teams that can be made? So first off, I want to figure out how many total basketball players signed up. So I'm going to add those numbers. 17 players from Friday, 12 players from Saturday, and 10 players from Sunday signed up. So we have 39 players that signed up. Now, if it takes 5 players to make a basketball team, I want to take those 39 players and divide them into groups of 5 to figure out how many teams, I'm going to call that T, can be made. I could represent this with a number bond here. I have 39 players, and I'm going to put them into groups of 5. 5, 10, 15, 20, 25, 30, 35, and then I have 1 player left, so I'm going to put that right here. But notice that's not going to be a team. That 1 player is going to have to be on one of those other teams because, again, it says it takes 5 players to make a basketball team. So I can see that I'm able to make 7 teams. And then 1 player would go on those, that 1 extra player would go on one of those teams. I can multiply multi-digit numbers. Solve 42 times 53. Here I'm going to use the area model. 40 and 2 are going to be the numbers I use for my columns. And then 50 and 3 will be the numbers I use for my rows. Now I'm going to find the area of each of the rectangles. So 3 times 2 is 6. 3 times 40, or 4 tens, is 12 tens, which is 120. 50 times 2 is 100. And 50 times 40, I can think of that as 5 tens times 4 tens. That's 20 hundreds, or 2,000. Now I'm going to add the partial products. I have 126 and I have 2,100. And now I can add those together and I end up with a product of 2,226. I can divide a 4-digit by 1-digit number. Solve using any method. I'm going to use the box method here. I have 2,324 in my initial box, and I'm going to divide by 7. So I'm going to make groups of 7. How many groups of 7 can I make and get close to 2,324? Well, I know 1 group of 7 is 7. That's not even close. 10 groups of 7 is 70. 100 groups of 7 is 700. 1,000 groups of 7 would be 7,000. So I don't want to go to the thousands. Back it up, and I said 100 groups of 7 is 700. I could start there. 100 groups of 7. I'm going to take 700 out of my box. I'm left with 1,624 in the box. That's going to be my next target number. Now I ask myself, how many groups of 7 can I get out of that 1,624 without going over? I know that 100 groups of 7 was 700, so let's do 200 groups of 7 this time. That would be 1,400. I'm going to subtract that from my box, and now I'm left with 224. How many groups of 7 can I get out of that 224? Well, I know that 10 groups of 7 is 70. 10 groups of 7 is 70. And so how about 3 tens, or 30 groups of 7? That would be 21 tens, 210. Let's take that out. We're left with 14. That's going to be my next box. 2 groups of 7 I know is 14, so I'll take that out, and I'm left with nothing. So my quotient, the answer to the division problem, is all of these partial quotients here added together. That would be 332. On the back side, I can add and subtract fractions. 3/4 plus 2/4. Well, fourths would be my whole broken into 4 equal parts. And I want to represent 3/4, so I'm going to shade in 3 of those 4 parts. And then if I add 2/4, then I could go, well, let's put another set of fourths. And I'll change colors here, and here's 1/4 and 2/4. So now we can see that we have a 1 whole and 1/4 of another whole, or 5/4. Subtract. Show your work. 5/8 minus 3/8. So now the units we're dealing with are eighths. I'm going to break my whole into 8 equal parts. I want to represent 5/8, so I'm going to shade in 5 of those 8 parts. And now I'm going to subtract 3/8, so that means I'm going to take away 3 of these eighths. And now you can see that I'm left with 2/8. I understand angles are measured with a reference to 360-degree circle with its center at the common endpoint of 2 rays. A circle measures 360 degrees. If the circle were divided into 3 equal parts, what would be the measure or angle measure of each part? Explain how you know. So here I'm going to put a center point in our circle, and we want to divide that circle into 3 equal parts and figure out the angle measure. So 360 degrees, I can think of that being divided by 3, divided into 3 equal groups, and that would tell me how much each of the sectors of my circle would measure. So I'm going to think of this 360 as 36 tenths divided by 3. Now I know 36 divided by 3 is 12, and my units are going to be tens. So 12 tens is 120. So 120 degrees will be the angle measure of each of the sectors in my circle that's been partitioned into 3 equal parts. I can determine the measurement of missing angles. Determine the measure of angle ABD. Notice that ray BD here is lined up with 0 degrees using our interior numbers. I also notice that this is an acute angle, so it's going to measure less than 90 degrees. So now I want to use those interior numbers and measure around to my ray BA. And I see that it goes to 82 degrees. I'm going to call this 82 degrees because here's 80 degrees right here. And it's about 2 little tick marks past that. That's all for today, math friends.